Okay, so you automatically know that this means that you have another 0, 3 minus 2i. So we have a couple of different options. I'm going to go ahead and go the long way first of all. So if I take, let's see, I've got 1, -3. So 3, 2, 1, 0. Make sure that I'm not missing anything. 39. If I divide that by, this is ugly, but I'm going to go ahead and use 3 plus 2i. So this is a 1. This is a 3 plus 2i, which means this is a 2i, which means this is a 6i plus 4i squared, which is -4, right? Because 6i plus 4i squared is 6i plus 4 times -1. Wow, that's ugly. Okay, so I've got -9 plus 6i. So now I got 3 plus 2i. Maybe I didn't want to do this. Maybe it was easier to do it the other way. -9 plus 6i. So I've got -27. And I've got first and then outer 18i. And then inner -18i. And then last. The last was these two. And I got 12i squared. These two canceled. I got -27 plus -12, which is -39. Phew, was canceled. Okay, so then I could do it again. I could use 3 minus 2i. This is 3 minus 2i, so that's just 3. So this is 6. No, this is 9 minus 6i. And that's 0. So this was x cubed. That means that this is x squared, which means this is just x's. So this is x plus 3. So x plus 3 is a factor. And that tells me that x equals -3 is a 0. This was my first 0. There was my second 0. I'm going to do this problem again. Let's see if it turns out prettier or not. There's a trick that if you do it the other way, there's a trick.
Yeah, it says the zeros are 3 minus 2i and -3.
Yeah. Okay, so I'm going to start over again. I'm going to do this problem again. I know that my factors, I have two factors, x minus 3 plus 2i and x minus 3 minus 2i. Do you see where I'm getting at?
Yeah.
I'm going to rewrite this, though, so I can do a bunch of this in my head. So that's x minus 3 minus 2i and x minus 3 plus 2i. So I'm going to group the x minus 3's together. Because I know that if this thing matches with this thing, and this thing matches with this thing, and the only difference is a plus and a minus, that I'm going to end up squaring that thing and squaring that thing and subtracting them. So I'm going to have x minus 3 squared, and I'm going to have 2i squared. And I've gotten pretty good at these. That's x squared minus 6x plus 9. And this whole thing gets squared. So that's 4i squared. Oh, and that was x squared minus 6x. And that's plus 4. So that's plus 13. What I just did is found out what those two factors multiplied up to. So what I can do is I can take my original function And photo bomber, video bomber. So x divided by x squared is x. So then x times x squared is x cubed. X times negative 6x is negative 6x squared. X times 13 is 13x. You know, a lot of times I suggest to write that work out on the side. Yeah, let's make that 3x squared. Let's see if that works better. And so that's going to be a negative 18, isn't it?
Yeah.
Okay, so it's nice that things work out cleanly because there's so many places to make mistakes, but there's also lots of ways to catch your mistakes. So 3x squared divided by x squared is 3. So then I got 3 times x squared, 3 times negative 6x, 3 times 13. And when they exactly match up, you know, they divide to 0.
Mm-hmm.
Okay. We just found that x plus 3 is a factor.
Mm-hmm.
Which meant that x equals negative 3 was a 0. So like I said, we just did the same problem over again, which helped me since it helped me catch my mistake.
Mm-hmm.
So, you know, 6 of one, half dozen of the other. Both ways of doing it are tedious. You do whichever way you want to do it. But that trick that I just showed you on the previous screen where you rearranged your parentheses, and then you could use the fact that it was a difference of squares. There are problems where you unfortunately do have to multiply those out. Those problems, you'll notice when you get to those problems, they don't have parentheses anywhere. You're not allowed to use parentheses, and so that's a clue that they're not going to let you use the factored form.